Okay, today we are going to review for Unit 2, proportional relationships. Remember, we're doing rates, unit rates, ratios, proportional relationships, constant proportionality. Those are all the things that you guys should be studying. Remember to look over your vocab, and there is a Quizlet that you guys can look at. Okay, so what we're going to go over is, so in class you guys got a purple version of this. It's just a little bit easier to see when I have it on white paper. Okay, so let's get started. So the first thing we're going to review is the difference between a rate and a ratio, or a rate and a unit rate. So now they are basically the same thing, but remember, for a unit rate, we want to make sure that the denominator is 1. Okay, so you guys are going to actually have to do a little bit of math. Crazy, I know, in math class. In order to make sure that these are correct. So, first things first, if you notice, all of these have examples of money. Okay, so money is going to be the thing we talk about first. So if we think about our ratios, we're going to have money over whatever. So whatever the other thing is. And the reason for this is because the money is the dependent variable, so it depends on what is on the bottom. That will tell us what the price is, and that's how we can find the rate. So let's get started. So for the rate for 9 batteries that cost $13, we would say that $13 per 9 batteries. Okay? And then to figure out the unit rate, we just do 13 divided by 9 in our calculator. You guys should get 1.44444. We're talking about money, so let's round. So $1.44 per battery. Okay, so again, the unit rate means 1. Okay, next one, $6 for 4 cans of tuna. So $6 on top, 4 cans on the bottom. That would be our rate. And then if we're getting specific, for the unit rate, we're going to divide 6 divided by 4, so we get $1. It'll say 1.5, but remember, money goes to the hundreds place. So $1.50 per can. Alright, 5 pencils for $16. Wow, that seems pretty pricey. So $16 on top, 5 pencils on the bottom. Do your division, 16 divided by 5, you should get $3.20 per pencil. I don't know what kind of pencils these are, but I'm not buying them. And the last one, $12 for 5 books. So $12 over 5 books. And after you divide, you would get $2.40 per book. I don't know in what world pencils will cost more than books, but what are you going to do? Okay, so there is our first portion. So you should be able to know the difference between a rate and a unit rate. If I gave you something like this, you should know how to write either of them or how to identify them. So if I gave you $13 over 9 batteries, you should tell me that's a rate, but $1.44 per battery would be the unit rate. Remember, our main example that we use for our unit rate is miles per hour. That's the one that is the most often seen. Okay, next part. Okay, so I'm actually going to show you something a little bit new. It's not really new, but it's an easy way to determine if ratios are equivalent. So what we've been doing in class is we've been simplifying each of these and then comparing if their simplified form is in fact equivalent. So 12 over 7, that would just stay 12 over 7. Can't simplify that anymore. And then 60 and 35, each of those are divisible by 5. So let's divide them by 5. Okay, so 60 divided by 5 is 12, and 35 divided by 5 is 7. So that actually does work. Glitchy. Okay. So yes, they are proportional. Now, I do want to show you an alternative way. And let me get a different color that's a little bit bright. Okay, so an alternative way that you can do is if you cross multiply, so we'll change this and to an equal sign, okay, and cross multiply. So equivalent ratios, the cross products are equal. Cross products are equal. So all that means is when you cross multiply them, they should get you the same answer. So if you do 7 times 60, that equals, I don't know why I wrote 6. 7 times 60 equals 420, and 12 times 35 also equals 420. Okay, so either way, if you want to simplify them, you would see that they are equal. If you cross multiply them, you would also see that they are equal. Okay, so now these, both looking at these are simplified, simplified. Okay, so this is definitely a no. These are both simplified, simplified, and they are not the same. So they are no's. Okay, but just to show you that the cross products won't be the same, so 81 is not equal to 22. Okay, and 12 is not equal to 10. So again, just another way that you can double check your work. Okay, and the last thing, if I give you a proportion with a missing value, you should be able to tell me what the right answer is. Okay, so looking at these, I see that I can multiply by 6, okay, to get 5. So to go this way, I would divide by 6. Oh, that's, sorry, it's early. Okay, we're dividing by 6 to get 5, and then multiply by 6, so 7 times 6 is 42. You can do it that way. The other way you can do this is, again, cross multiplying. So if we cross multiply, we get 2z equals 40. 2 times z, to undo that, we divide. So after we divide by 2, x equals 20. Okay, and if you look at this, so to get from 8 to 2, we have to multiply by 4. So if we went backwards, that would work. Okay, and the last one I will also cross multiply. So I get 7a equals 5 times 42 is 210 divided by 7 divided by 7. So a equals 30. Okay, on to the back side. Okay, so now we have a table. Alright, so I didn't want to give you a super easy one and then give you a really hard one on the test, so I figured we would do a hard one right here, and then we will be overly prepared for our quiz. Okay, so the first thing we want to do, let's see, we have number of apples, that's going to be our x value, and then our weight is going to be y. Okay, so the first thing we have to figure out is what are we multiplying by each time in order to solve this. Remember, whatever we have to multiply by, that is called our constant of proportionality. So k is equal to y over x. Well, the only one we have is 0.6 over 5. So if we put that in our calculator, k is equal to 0.12. Now notice, this is for 1. Okay, this is like our unit rate. So this means that 1 apple weighs 0.12 12/100ths of a kilogram. Okay, so every time we are going to multiply by 12/100ths. So go ahead and put that in your calculator, and you should get 24.24 and 1.44 or 1 44 hundredths. Okay? Alright, so A is done. Next one, constant proportionality. We already did this one. So K equals 0.12, which means each apple weighs 12/100ths of a kilogram. Pretty tiny. Okay, next thing we're going to do is write our proportional relationship equation. Okay, so an equation needs to have an equal sign. Okay, when you see equation, you should be thinking equal sign. So for our equation, and I'm going to move this down. Okay, remember you guys can pause at any moment. When I move it down, I have to erase everything just so my screen is nice and clear. Okay, so for our constant proportionality, we said that K is equal to, K is equal to 12/100ths. Okay, so remember, Y is always going to be on the outside. So Y equals, and then we are multiplying by K. So Y equals 0.12 or 12/100ths x. Okay. Alternatively, you could say an A for apple and a W for weight. So if you do that, again, we are multiplying the number of apples to figure out our weight. So it would be W equals 12/100ths A. Okay, so either of these would be acceptable. Notice how above the apples I wrote an A in parentheses and weight. That's kind of like a let statement. Okay? And the last thing, so if 20 is how many apples we're talking about, what we're going to do is we're actually going to substitute into our equation. So Y equals 12/100ths times 20. Okay? So if we solve that, we would get 12 apples equals 2.4 kilograms, or 20 apples rather, 2.4 kilograms. Okay, so that will definitely be on the quiz, so make sure that you can work through a question like that from beginning to end. Okay, and the last question is an old state test question, so I thought I would throw that in there. So the first thing, so Andy rode his bike at a constant speed. Okay, so we know that it's going to be a proportional relationship because it is constant. He rode 1 mile in 5 minutes. So 1 mile over 5 minutes, that would be the rate. Okay, which of these equations represents the amount of time in minutes that it takes him to ride the distance of D? Okay, so they're saying T equals time. All right, so T and D, those are our variables. Okay, now the first thing I'm going to do is I'm going to cross off C and D because we haven't done any proportional relationships that look like this, and the reason why is because a proportional relationship is never going to have addition or subtraction sign in the equation. Okay? Now the next thing, this is meant to trick you. Alright, and I'll explain why. So this shows right here that for 1 mile, it takes 5 minutes. Okay? So most likely, you guys are going to pick B. But what I'm going to show you is we are going to use substitution. Okay? We're going to use substitution in order to, so the miles, that would be D, and the 5 minutes, that would be T. So what we're going to do is we're going to substitute into both of these equations. So T equals 5D and T equals 1/5 D. So what you guys are going to see is I'm going to substitute in. So T should be 5 minutes, okay, and then D is 1. So all I did was I took each of these values, and let me just put my blue, okay, so 5 is right here, so I substituted in where I see T, and then D we see is 1, so I put it right in here, okay. Now what happens, I'm not solving anything, I'm just, it's kind of like a check. So since 5 equals 5, that one actually works. So the answer is A, but I just want to show you why this one doesn't work. So T, again, is 5, and then if I substitute D in, okay, 1/5 times, so 5 is not equal to 1/5, so it cannot be B. Okay, so you would just substitute in, and that's how you can check for a proportional relationship. Okay, so in addition to studying, again, yours is a purple sheet, so in addition to studying your packet, these questions, please make sure you study vocab. Okay, there will be a vocabulary section, so please make sure you study vocab. Okay, and our quiz is tomorrow.